Although the main purpose of this video is to explain the advantages of the switched mode power supply, it won't do any harm to go over the basics of all transformers first. Let's begin by thinking about the humble electromagnet. If you can understand electromagnets, then the concept of transformers follows on naturally from that. So if we pass a current through a coil of wire, it creates a magnetic field around it. This is a solenoid. If we do the same with the addition of an iron core, then we have what is called an electromagnet. There's a handy way for remembering which end becomes the north and which is the south. The next thing we need to recall is that moving a permanent magnet into a coil of wire induces a current in that coil while the magnet is moving. So moving a magnet in and out of a coil can generate electricity. This is the basis of how a dynamo or a generator works, but that's for another talk. Now, we can put these two ideas together. If we put an alternating current through a coil, it creates a constantly changing magnetic field. If this constantly changing field is then linked to another coil, then the field produced by the first coil induces a current in the second. Varying the number of turns on these two coils enables us to step up or step down the voltage. For example, if the secondary coil has twice as many turns as the primary coil, then the voltage out will be twice the input voltage. So that's the basis for how any transformer works. But what about these new ones? What's so special about the switch mode power supply? Well, the main advantages are that they can be lighter, smaller, and waste less energy if you happen to leave them plugged in and switched on after removing your mobile phone. So they're lighter, they're smaller, and they waste less energy. Are there any disadvantages to them? Well, that depends a lot on the build quality. Strictly speaking, you don't need to know any details about their internal makeup, but I suspect many of you listening will be curious, and delving a little deeper may just help you to remember the reasons behind the pros and cons. Traditional transformers work at mains frequency, that's 50 Hz in the UK and Europe, and it turns out that the best medium to transfer the magnetic field from the primary to the secondary is a large, heavy iron core. Modern switched mode power supplies have their transformer component running at somewhere between 50 kHz and 200 kHz. And it turns out that if you do this, you don't need the heavy lump of iron at all, just a small ferrite core, which is a tiny fraction of the weight. Of course, some of you will be wondering how we suddenly have 50 to 200 kHz if the mains frequency is only 50 Hz. This is achieved using some clever electronic circuitry. Now, this appears to be the only real downside to this type of transformer, the number of components. Just look at them all. In addition to the ferrite core transformer, that's that little yellow cuboid, I count 21 large components soldered on top of the circuit board, plus a host of tiny surface mount devices on the other side. If the soldering is not done well, I can see one of these things going wrong after a couple of years, whereas the old-fashioned type is really simple. 2 coils, a heavy iron core, and a few simple components to turn the AC to DC and to smooth it. So to sum up, all types of transformers can change the voltage. If they're step up, more turns on the secondary than the primary, then they increase the voltage. If they are step down, fewer turns on the secondary than the primary, they decrease the voltage. So switch mode power supplies are like traditional iron core transformers in this regard, but they have their own distinct characteristics. The pros, they are smaller, they're lighter, and they draw next to no current when they're not in use. The cons, many more components increase the likelihood of failure if they're not well designed or well constructed. That's all you need to know, but hopefully you now know something about why these modern inventions perform the way they do.